Hello, my dear students. Welcome to 10th standard online classes in our YouTube channel as well as in Google Classroom platform. In the last class, dear students, we came to know about these points. Let me recap what we learned in the last period. So, first point, the first law of refraction. The incident ray normal to the transparent surface at the point of incidence and refracted ray all are lying on the same plane. So that is our first law. The ratio of sine angle of incidence to the sine angle of refraction is a constant. In other words, the ratio of sine of angle of incidence to the sine of angle of refraction, that is taken as constant, so which will be our second law. These two laws are called as laws of refraction. And we also got the two terms, absolute refractive index or simply refractive index, and another one, relative refractive index. So absolute refractive index is defined as the ratio of speed of light in air or vacuum to the speed of light in the medium, or you say that reference medium. That is nothing but absolute refractive index. Relative refractive index is the term when the light is passed through medium 1 to medium 2. The refractive index of medium 2 to medium 1 is known as relative refractive index. We got their formula too. So these are the definitions, and we also got the information about different refractive indices for different material media. So these are the points which I have discussed in the last lecture. In today's lecture, we are moving further, that is refraction through spherical lenses, or you say that refraction by spherical lenses. We are getting the refraction this time in spherical kind of lenses. Okay. Then what do you mean by spherical lenses? The question arises, what do you mean by spherical lenses? A spherical lens is a piece of transparent medium. It is a piece of transparent medium bounded by at least one spherical surface. Okay, a piece of transparent medium bounded by at least one spherical surface. We may have more than one spherical surface, that is okay, but at least we require one spherical surface. Okay, that is known to be as spherical lens. It is oftenly called as lens itself. We just call it as lens too, no problem. So whenever we are talking of lens, it has to be most of the times as spherical lens only, and hence we taken it as lens itself. Okay. Again, a piece of transparent medium bounded by at least one curved surface is known as spherical lens. So this is the picture showing different lenses here. Just we have collected these three. So there are different types maybe. So don't worry about that. Let us take those types one by one now. There are two kinds of lenses or two types of lenses. One is convex lens and other one is concave lens. You probably studied these things in lower classes. Just I am reminding that by giving the definitions, by giving the informations which you have learned, by that those things will be coming into the mind to get the main things in this year right. Okay. So the first type will be convex lens. First one will be convex lens. So this is the picture showing the convex lens. So these are the picture which I have collected. I hope you are getting these pictures right. By that I can define these things to you easily. The type of lens, it is the type of the lens having both spherical surfaces or one spherical surface and other will be the plane surface, that it is thick at the middle and thin at their edges is known as convex lens. Remember, we have three different types of convex lens which I am going to discuss in short time. So here I am defining the convex lens as it is a type of lens having both spherical sides maybe, or one spherical side, or one spherical side and other surface will be plane. So that is taken as convex lens. So by that one can get thick in the middle and thin at their edges. Compared to this is thick in comparison with these 2 points. Okay, this type of lens is known as convex lens. So this is the another picture for convex lens. I hope you are getting that. This type of lens is also known as converging lens. It is also called as converging lens because they are converging the light to one point, just like concave mirror. The concave mirror, which is called as convergent mirror. Similarly here, convex lens is called as converging lens. Okay, because when you pass the light on this, so what happens? It is going to meet, so those rays of light going to meet at this point. So that is the reason why it is called as converging lens. It converges the rays of light. Okay, that will be discussed thoroughly in the upcoming classes. The reason I'm bringing it is converging the rays of light and hence the name converging lens. That's the justification for you. There are three types of convex lenses. They are biconvex or double convex lens, plano-convex lens, and concavo-convex lens. So convex lens, we got that. It is the type of lens which have spherical surfaces together, or one spherical surface or other side is plane. Okay, by that by the middle portion becomes thick and edges are thin. Okay, this is the convex lens. Now there are three types, as I said, that biconvex lens or double convex lens, plano-convex lens, and concavo-convex lens. Okay, these are the three different types of convex lenses. So let us check those one by one. So the first one, biconvex lens, that is called as double convex lens too. It is a lens having both surfaces convex. So this is the surface number 1. This is the surface number 1 and this is the surface number 2. So both surfaces are convex. Then that is known as biconvex or double convex lens. So the lens having both surfaces convex. Okay, so this is the double convex lens for you. And second one will be the plano-convex lens, the lens having one surface plane and other surface convex. That is taken as plano-convex lens. Planar plus convex, that is called as plano-convex lens. Okay, these are the types of convex lens, hence the name written convex in the end. So plane is taken first, plano, then convex lens. Therefore, plano-convex lens. So this is the second definition. the plano-convex lens, concavo-convex lens. So it is the mixture of concave as well as convex lens. Okay. Concavo-convex lens means concave plus convex lens. Okay. It is the lens having one surface concave, and other surface convex. So this is the convex part, and this is the concave part, and hence the name concavo convex lens. I hope you got these definitions right. There are three kinds. One is biconvex or double convex, where you find both the surfaces convex. In plano-convex lens, we have one surface plane and other surface is convex. And in concavo-convex lens, one surface is concave and other surface is convex. I hope you got all these things right. Next one, that is concave lens. Next one will be the concave lens. The type of lens having both spherical surfaces, or one spherical surface and other one again it is plane. By that, it is thin at the middle. This is exactly opposite to that. By that, thin at the middle and thick at their edges. So this is thin at the middle, thicker at their edges. By that, it is appearing like this. This type of lens is known as concave lens. Okay, thinner at the middle, thicker at the edges. Such kind of lens is known as concave lens. Okay, so this is the picture showing for concave lens. If you can, so go through to this, come to know at least a fair bit of idea about the lenses. Okay. So these types of lenses are also called as diverging lenses. These are also called as diverging because when you pass the light on such lenses, what happens? The rays going to diverge from one another. Just in case of convex mirror is called as divergent mirror. Similarly here, this type of lens is called as diverging as they diverge the light rays. Okay, this is called as divergent lens. Again, there are three types: double concave lens, plano-concave lens, and convexo-concave lens. There are three types: double concave lens, plano-concave lens, and convexo-concave lens. Let us check those three types now. So the first one will be the double concave lens. Again, this is a type of lens having both surfaces concave. Both surfaces 1 and 2 are concave, and hence the name double concave lens. So this is the first one. Second one, plano-concave lens. It is a lens having one surface plane. You better take this time 1 and this as 2, or you may take 2 1. It's not at all a problem. So one side will be plane and other side will be concave, and hence the name plano-concave. Planar plus concave lens is taken as plano-concave lens. Similarly, convexo-concave. So this is the concave part and this is the convex part, and hence the name convexo-concave. One surface is convex and other surface is concave. You can take even 2 1 just to maintain the rhythm, right? You written 2 1 2 1 all the time. You write it 2 1 2 1, no problem. Okay, so this is the concave part and this is the convex part. By that you can get convexo-concave lens. The mixture of convex as well as concave kind of lens is known as convexo-concave lens. So these are the basics regarding lenses are concerned, spherical lenses, in fact, I hope you got all these things right. Let us move to the next part, that is terms associated with spherical lenses. So the first one, for first term you say associated with the spherical lens will be the aperture. Okay. Aperture is the diameter of circular edge of the lens. So this is the diameter of circular edge in the lens. If you are drawing two spheres like this, just to continue this, you will get this picture, right? In fact, it will move beyond this. Actually, I'm not able to write that because center of curvature somewhere here. Better you draw somewhere on the other side. Assuming this is the first sphere and this is the another sphere. We have two spheres, 1 and 2. So the aperture means what? The diameter of circular edge of the lens. The diameter of circular edge of the lens. I mean, I'm talking these 2 points, this and this. Okay, just to change the color, by that you can recognize those points easily. This is the first point and this is the second point. The diameter of circular edge of the lens. You take it as this point A and this point as B, and hence in the diagram AB, the portion AB represents the aperture, the diameter of circular edge of the lens. So the diameter of circular edge of the lens is known as aperture. So the points A and B in this diagram showing, which means it is covering the entire portion. That is nothing but aperture of the lens. So first you need to draw this. This is the picture I am taking directly, and I will tell you how to draw all those things in the upcoming classes for sure. But just try to understand the technical terms appearing in front of you. By that you can get the things right. Okay. So second term, that is center of curvature. Center of curvature. It is defined as center of the spherical surface. Center of the spherical surface from which the lens has been cut out. Okay. It is the center of the spherical surface from which lens has been cut out. As I said that these are the points. This is the sphere number 1 and this is the sphere number 2. The center of those two spheres where you cut out the lens. So this portion and this portion is taken as the lens. So the center of those imaginary spheres is known as center of curvature. It is known as, that portion is known as center of curvature. Remember, each surface of the lens is a part of sphere. Each surface of the lens is a part of sphere, and there will be always two center of curvatures in case of spherical lenses. Okay, there are C1 and C2. There are points C1 and C2 in the diagram. So these are the, again, if you extend this diagram, which is going to pass our limit, therefore you just bring that C1 as the center of sphere or center of curvature, that is the center of curvature C1, and this is for the first imaginary sphere, and C2, that will be the second center of curvature for the second sphere. I hope you are getting this. This is very simple. As you are progressing towards this part, you will come to know. Therefore, no worries at all. Okay. C1 and C2 are called as centers of curvature. And one more thing I can add here at this point of time. It can be drawn to concave mirror also. Concave lens also is not the final one. Okay, you can do it for concave lens also. So you drawn for converging lens, that is convex lens. It can be done for concave too. Next one, that is principal axis. An imaginary straight line, that is an imaginary straight line passing through the two centers of curvature of spherical surfaces of the lens is known as principal axis. These things are quite similar to the terms which we have discussed in the mirrors case, but just to go through, this is the lens, so that some technical parts are going to differ from that side and rest are almost same. Okay, this is the trick. By that you can analyze the things right, analyze the terms right. So the principal axis is an imaginary straight line passing through two centers of curvatures of the two spherical surfaces of the lens is known as principal axis. Here the imaginary line which is passing through C1 to C2, this line is known as principal axis. Okay, it is the imaginary line passing through center of curvatures or centers of curvature for you call it as centers of curvature for convex lens. This is simply principal axis. So I'm gonna pause here at this point of time with some more terms related to spherical lenses, which I'm going to discuss in the next period. Till then, take care of yourselves and bye bye.